Have you ever stopped to think about what happens to the millions of old tires discarded every year in the United States? Most people simply throw them away, stack them in the back of the garage, or wait for someone to haul them off, never imagining for a single second that what looks like garbage is about to go through one of the most impressive and least known industrial transformations on the planet. What you're about to discover is a process that the automotive industry prefers to keep out of the public eye, not because it is illegal, but because it is too disturbing for anyone who believes that an old tire is nothing more than trash. Welcome to the inside of one of the most secretive and profitable factories in the United States, where dead rubber comes back to life with a precision that defies all common logic. We are not talking about simple recycling. We are not talking about grinding tires down and turning them into gym floor mats. What happens inside these high-technology industrial facilities scattered across the American interior is a complete, technical, millimeter-precise, and extraordinarily profitable tire restoration process that supplies fleets of trucks, aircraft, and heavy vehicles with retreaded tires that pass inspections just as rigorous as those applied to brand new ones. The industry moves billions of dollars every single year, and the end consumer rarely knows that the tire rolling beneath the semi-truck passing them on the highway may have had an entirely different life before this one. The first thing that shocks any visitor who manages to get inside one of these industrial plants is the smell. Hot rubber, solvents, humid heat mixed with the weight of compressed air moving through pipes running in every direction. It is an environment that assaults your senses before you even begin to understand what you're looking at. Stack after stack of used tires arrive on trucks, organized by size, by brand, by degree of wear, as if they were components waiting to be evaluated by a forensic specialist. And that is exactly what happens in the first stage of this process, an inspection that most people never imagined could be necessary or even possible. Every tire that enters this hidden factory at the heart of industrial America must prove that it still has enough structural integrity to receive a second life. Trained operators run their fingers along the interior surface of the carcass, searching for separations invisible to the naked eye, for deep cuts that compromise the internal steel, for deformations that no new rubber could ever correct. Those that do not pass the initial screening are sent off to conventional recycling. The ones that make it through enter a production line that will completely transform their appearance, their surface structure, and their performance, without ever touching the internal carcass, which is precisely the secret behind this entire shocking process. What most people will never get to see is the moment when a large industrial scraping machine, known as a buffer, begins spinning the tire at high speed and removes every last bit of old rubber from the tread surface, millimeter by millimeter. It is a visual spectacle that looks destructive but is calculated with an almost absurd level of precision. Rubber particles fly in every direction, sucked up by ventilation systems that capture every single fragment for reuse in other products. The tire that entered the machine with a worn, cracked and useless surface comes out with a perfectly uniform carcass, ready to receive a new layer of rubber like a blank canvas waiting for a master craftsman. And this is where the real secret process begins. Before we continue pulling back the curtain on every stage of this process that the industry works hard to keep away from the public, I need a moment with you. If this kind of content shocks you, surprises you, or makes you see the world in a completely different way, go ahead and type the word "restored" in the comments right now. That is the signal that you are truly understanding what is being revealed here. Also, hit that like button on this video because it helps this information reach more people who go through life without knowing what happens behind the scenes of American industry. And if you are not yet subscribed to this channel, do it right now, because what comes next is even more disturbing than everything you have seen so far. After the buffing stage, the tire enters an electronic inspection chamber that very few people outside the industry have ever heard of. An ultrasound device travels across the entire surface of the carcass, searching for any air pockets, layer separations, or structural inconsistencies that the human eye would never detect. This stage is the heart of the quality control process, the moment when the machine decides whether that tire will continue its restoration journey or be discarded without appeal. Approval rates vary, depending on the strictness of each facility, but in high-standard plants that serve airline and military fleets across the United States, more than 30% of tires are eliminated at this stage, even after having already passed the initial screening. This means the finished product that reaches the customer is the result of a brutal selection process that begins long before any new rubber is ever applied. The approved tires move on to the surface preparation stage, where operators apply a special chemical bonding cement, a high-performance adhesive that will create a molecular bond between the old carcass and the new rubber that will be applied over it. This cement is not something you would find at any ordinary tire shop. It is an industrial formulation developed to withstand extreme temperatures, pressure variations, and the repeated deformation cycles a tire endures with every single mile it travels. The application must be uniform, controlled, free of bubbles, and free of excess, because any irregularity at this stage will become a permanent defect that no subsequent process will be able to correct. Operators wear specialized masks and gloves because prolonged contact with these chemical compounds can cause severe skin and respiratory irritation. It is at this point that the production line splits according to the retreading method being used. There are basically two main processes used in the United States, and each one produces a different result in terms of appearance, performance, and final application. In the first method, known as hot retreading, a new batch of raw rubber compound is placed directly over the prepared carcass and molded in industrial presses that reproduce the new tread pattern with a precision measured in fractions of a millimeter. The heat applied during this process vulcanizes the rubber, creating a permanent chemical bond that fuses the old carcass and the new material into a single unified structure. In the second method, known as cold retreading, a pre-cured tread band, already formed with the complete tread pattern, is applied over the cemented carcass and then subjected to a curing process inside an autoclave, a pressurized chamber that operates at precisely controlled temperatures and pressures to guarantee perfect adhesion between the two materials. What impresses outside observers most is the speed at which these industrial machines operate without sacrificing even a fraction of their precision. A hot retreading press can process hundreds of tires per shift, each one coming out with the perfect tread pattern, the correct measurements, and the appearance of a completely new product. On the lines that serve large trucking fleets, the process is essentially continuous, with buffed carcasses entering from one side and finished products coming out the other, ready to be mounted and put back on American roads. The logistical efficiency of these operations is as impressive as the technology being used, and it is one of the primary reasons why this market moves figures that most people would never associate with used tires. After vulcanization or autoclave curing, the tires go through one final round of visual and dimensional inspection that would be considered excessive in most other industrial processes, but is treated here as the bare minimum. Every groove is measured, every sidewall is examined, every inch of circumference is verified against the original manufacturer specifications. Tires that show any deviation outside established tolerances are marked, separated, and discarded without ceremony. Only those that meet 100% of the approval criteria receive the certification seal that authorizes their exit from the factory and their entry into the retreaded tire market. In the United States, this entire process is regulated by the FMCSA, the federal agency that oversees commercial transportation safety, and the penalties for companies that put non-conforming tires into the market are severe enough to keep the entire industry aligned with the strictest possible standards. What very few people know is that American aviation depends directly on this technology. The tires used on commercial aircraft in the United States are retreaded an average of 6 times before being permanently discarded, and each restoration cycle must meet standards even more rigorous than those applied to truck tires. The facilities that serve the aviation sector are completely separate from conventional retreading lines, operate with specialized equipment, and employ technicians who hold certifications issued by the FAA, the Federal Aviation Administration. A retreaded aircraft tire must withstand landing forces that can reach loads equivalent to hundreds of times the weight of the tire in fractions of a second, repeated dozens of times every day, year after year. The fact that this tire went through an industrial restoration process before touching the runway is something most passengers prefer not to think about as their plane lifts off the ground. The environmental impact of this industry is another point that the sector is eager to highlight, especially at a time when sustainability has become one of the most powerful selling arguments in any market. Every retreaded tire saves an average of 5 quarts of oil compared to manufacturing a brand new one, while also dramatically reducing the generation of solid waste. In the United States, where more than 250 million tires are discarded every single year, the retreading market represents a significant diversion of that waste volume. The rubber shavings generated during the buffing phase are reused in rubber flooring, synthetic soccer fields, and asphalt mixtures applied to highways across the country. The process that looked destructive at first glance is, in fact, one of the most efficient and complete industrial cycles that American industry has developed over the past century. And at the end of this entire journey, the tire that arrived at the factory as a discard, with a worn surface and the appearance of something that had no further use, leaves transformed into a functional, certified, cost-effective product, capable of traveling tens of thousands of miles before requiring any new intervention. A complete second life, built on the foundation of the first, with technology, control, and an industrial precision that most consumers would never associate with something that was once thrown away. You will never look at another old tire on the side of the road the same way again. You can count on that, Anne. Now here is the question that remains. Did you ever suspect that tires could go through a restoration process this complete and this rigorous? Or did you always believe that an old tire had only one possible destination? Write in the comments what surprised you most about this process, and let us know if you have ever driven or currently drive a vehicle running on retreaded tires without even realizing it.